Bismillahirrahmanirrahim. This video will be solving practice problem 9.8 from Mr. Hayt's book. And for this also, the student from Singapore has requested. And this question, let's see, this is the question. It says, find an expression for ILT and the circuit and figure. So this is the circuit. This current is the current through inductor IL. Voltage across the capacitor is called VC, and there is a dependent source, current source, whose value is equal to 3 times the capacitor voltage. And also, the circuit is valid for t greater than 0, and the initial conditions are given, that is VC0 is 10 volt, and IL0 minus is 0. A very important note has been given, which I also ignored, and I'm sure many of the students are ignoring. That is the note that although it is not helpful to apply Thevenin's technique in this instance. Now, actually, the example 9.8, this is practice 9.8. In example 9.8, he has applied Thevenin's technique and solved it. This question is almost similar to that, and that is why everyone tends to apply Thevenin's technique. But keep in mind, do not try Thevenin's as we have done in example 9.8. The second part of the note is saying that the dependent source, this is the dependent source, links VC and IL such that a first order linear differential equation results. This is again very important since there are two sources, two energy sources. So logically there should be a second degree equation. But since he's saying that this will result in a first order linear differential equation, therefore we have to again not follow the formula given for the series RLC circuit. Rather, there will be a very simple technique actually, and this after a lot of effort, I found from this forum, physics forum, nascent oxygens, and he gave the hint which I have used in solving this. So thanks to you. Okay, now let's solve. These are the initial conditions that are given. And the question says you have to find an expression for ILT, current through the inductor. And as we just learned that the dependent source links VC and IL. So we have to keep this in mind. So the logical sequence should be to find an expression for ILT. We can proceed as finding VCT. If we find VCT first, and then IC, the current through the capacitor, the formula is given as C dVC dt. And since IC and IL are same, we can then use this value of IC, find ILT. So we'll follow this method. Now, the first equation we can write is just from here. The current, you can see the current IL is clockwise, but this current is going the anti-clockwise. Therefore, we can write that IL is equal to minus 3 VC. Remember, this is the current. The current is actually written as 3 VC. So IL is equal to minus 3. This is equation number 1. And the equation number 2 is, as we mentioned here, that we will find IC, which is equal to IL, by using C dVC dt formula. We all know the current through the capacitor formula. And so putting these two, now this is here, so minus 3 VC can be written as C dVC dt. And from here you can write C dVc dt is minus 3 Vc divided by this capacitor C. Putting in the value of the capacitor, which is 10 millifarad, so 10 millifarad, and solving, we find it to be minus 300 Vc. So our equation now becomes like this, dVc, and we bring it to the left side. So 300 Vc is equal to 0. And this, as you can see, is the first degree linear equation or first order linear differential equation that he has mentioned in the hint. Okay, so this is up to this point we have arrived. Initial condition, just for remembering, I'm noting it down. Now, if we compare this with the first order differential equation for the RC circuit given in the book as dV dt plus V over RC is equal to 0. The first part is same, V or Vc. And the second part, if we compare, then from here we can find that 1 over RC is equal to 300. Okay. And the general equation from this, we can find the equation for Vt given in the book as equation 14 is this term, Vt or Vct is V0, that is the initial voltage, e raised to the power minus t over RC. So in our case, what will happen will be, now V0 is 10 volt, so we write 10 volt. 1 over RC is 300, so it will be minus 300t, e raised to the power minus 300t. This will be our VCT. And now we need to find ILT. Just use this formula. So ILT is C dVc dt, and C is this value, and then D of Vc. And solving, I hope you can find all this value. The 10 comes out and minus 300 comes out. So this equation is actually minus 30 e raised to the power minus 300 t ampere. So this is the answer that we are looking for. And the book answer is also the same. Minus 30 e raised to the power minus 300 t ampere for t greater than. So it's so simple. I hope you enjoyed. Please let me know through your feedback. Thank you.